Two dots on a graph, how far apart are they? Exactly. And if a point splits the line between them in a 3-to-1 ratio, where does it land? Coordinate geometry answers both with two formulas, and once they click, you'll never count squares on graph paper again. Let's build them. Start with distance. Drop 2 points, P and Q, and join them. Then build a right triangle underneath. The horizontal leg is the difference in the x's, x2 minus x1. The vertical leg is the difference in the y's. Pythagoras finishes the job. The distance squared is the sum of those two squares. So the distance is the square root of bracket x2 minus x1 squared plus we2 minus we1 squared. 2 quick notes. First, the distance of a point from the origin is just the square root of x squared plus y squared. Second, the order doesn't matter. x2 minus x1 squared is the same as x1 minus x2 squared because squaring kills the sign. And distance is always the positive root. Try it. The distance between 2, 3, and 4, 1. The x difference is 2, the y difference is minus 2. Square them, 4 and 4, and add to get 8, so the distance is root 8, which tidies up to 2 root 2. Done. Now what the formula unlocks. 3 points are collinear, on one straight line, exactly when the two shorter distances add up to the longest. AB plus BC equals AC. If they fall short, you've got a triangle instead. Distances also name shapes. A triangle is right-angled when side squared plus side squared equals the longest side squared. A quadrilateral with all 4 sides equal and equal diagonals is a square. All sides equal but unequal diagonals is a rhombus. You classify the whole figure just by computing lengths. One more move, equidistant points. A point that's the same distance from A and from B sits on the perpendicular bisector of AB. To find one on an axis, set its coordinates, like 0, y, on the y-axis, and set the two squared distances equal. For A, 6, 5, and B, minus 4, 3, that gives y equals 9, so the point is 0, 9. Pure algebra, no drawing. So we can measure between 2 points. Now let's land on a point between them. The second big tool, the section formula. Say a point P divides the segment from A to B in the ratio m1 to m2. Its coordinates are MEM1 times x2 plus m2 times x1 all over m1 plus m2, and the same pattern for y. The one thing to burn in, m1 multiplies the far point b. Swap them and you'll get the wrong point every time. Use it. Divide 4 minus 3 and 8, 5 in the ratio 3-to-1. The x is 3 times 8 plus 1 times 4 over 4, that's 28 over 4 equals 7. The y is 3 times 5 plus 1 times minus 3 over 4, 12 over 4 equals 3. The point is 7, 3. Here's a trick. Write the ratio as k to 1, and the formula gets simpler. The denominator is just k plus 1. This shines when you need to find a ratio. Ask, in what ratio does the y-axis cut a segment? On the y-axis, the x-coordinate is 0, so set the x formula to 0 and solve for k. That single step hands you the ratio. The friendliest special case, the midpoint, where the ratio is 1 to 1. The formula collapses to simply averaging, half the sum of the x's, half the sum of the y's. The midpoint of 2, 3, and 8, 7 is 5, 5. That's it. 2 more the exams love. Trisection points split a segment into 3 equal parts. Just the section formula at 1 to 2 and 2 to 1. And a parallelogram, its diagonals bisect each other, so the midpoint of one diagonal equals the midpoint of the other. That one equation finds a missing vertex. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Section formula, ratio 1 to 3. The x is 1 times 8 plus 3 times 4 over 4. 20 over 4 equals 5. The y is 1 times 5 plus 3 times minus 3 over 4. Minus 4 over 4 equals minus 1. So, 5 minus 1, option B. Lock it in. Distance is the root of the squared differences. The section formula lands a point in any ratio, m1 times the far point, and the midpoint is just the average. 3 formulas the whole chapter. Last challenge, it's on the screen. Don't say it aloud. Type your answer in the comments and I'll pin the right one. And that's coordinate geometry. Distance, section, and midpoint, all from a right triangle and a ratio. Free notes with 60 practice questions are in the description. Subscribe for the next chapter. This is Clarix. Keep going.